Hi, this is K. Sridhar, studied in Shankara Institute of Technology, CSCA section. I am explaining about subject is machine learning. Machine learning CART. CART means classification and regression tree. Components of classification problems. Outcome are dependent variable. They can be continued, categorical, ordinal, normal, or time to event variables. Example 1, example 2. Boolean pressures, patient servers, need for the surgeries, presence of micrological instructions, medicines, compilers. Predict are independent variables. Example 1 and 2, same examples with 3. Learning data set. This is a data set which includes values for both the outcome and predictor variables from a group of patients similar to these for whom we would like to be able to predict outcome in the future. Test data set. It consists of a patients from whom we would like to be able to make issues prediction. This test data set may or may not exist in practice. However, a separate test data set is not always required to determine the performance of a decision tree. A decision problem can include two other factors to be considered: a prior probability for each outcome, which represent the probability that a randomly selected future patient will have a particular outcome; decision cost or loss function, which represents the inherent most associated with the error in the prediction. For example, it is more services error in classify a patient within an emergent medical condition as non-urgent than to misclassify a patient with a non-urgent medical condition as urgent. Features of CART nodes: parent node, child node, root node, terminal node. Binary splits. A node is a decision tree can only be split into two groups, each split based on the only one variable, recursively partitioned. Binary partitioning process can be applied over and over again. Each parent node can give rise to child nodes, and in turn each of these child nodes may themselves be split, forming additional children. To construct a cart. Tree building. A tree is built using recursive splitting of nodes, building a maximal tree based on some stopping rule. A maximal tree has been produced which probably greatly overfitting the information contained within the learning dataset. Optimal tree selection. The tree which fit the information in the learning dataset but does not overfit in the information is selected from the among the sequence of pooled trees. The tree building. Tree building begins at the root node, which includes all patients in the learning dataset. Beginning with these nodes, the CART software finds the best possible variable to split the node into child nodes. In order to find the best variable, the software checks all possible splitting variables, calling splitters as well as possible values of the variable to be used to split the nodes. In choosing the best splitter, the program seeks to minimize the total purity of the two child nodes. Measure of impurity of n node P1, P2, P3 and Pk. Information are entropy equal to sum P log P with 0 log 0 equal to 0. Gini index G equal to 1 minus sum P into P. We define the impurity of a tree to be sum over all terminal nodes of the impurity of a node multiplied by an proportion of classes that reach the node of the tree. The predict classes assigning the each terminal node depending on the three factors: assumed prior probability of each class within future dataset, decision loss or cost matrix, and fraction of subjects with each outcome in the learning dataset that end up in each node. Stop tree building. The tree building process goes on until it is impossible to continue. The process is stopped when all observations within each child node have the identical distribution of the predictor variable, making the splitting of impossible. Next one, an external limit on the number of levels in the maximal tree has been set by the user. An external limit on the size of the terminal nodes is the maximal tree has been reached. Tree purned. In order to generate a sequence of simpler and simpler trees, each of these candidates are the appropriate fit final tree. The method of the reduced error pruning can be used. Each time we remove the weakest link that provides least improvement in misclassification. The misclassification error gradually increased during the pruning process. More generally pruned in possible cost complexity pruning. Optimal tree selection. The maximal tree will always fit the learning dataset with a higher accuracy than any other trees because the maximal tree is constructed to optimize the performance based on the learning dataset. The goal of in selected in optimal tree defined with the respect to expected performance on the independent set of data to find the correct complexity parameters so that the information in the learning dataset is fit up but not overfit. In general, finding this value of would require an independent set of data, but this requirement can be avoided using the technique of cross validation. The figure below shows in the relationship between the tree's complexities reflected by the number of terminal nodes and the decision cost for the independent test dataset and the original learning datasets. As the number of nodes increases, the decision cost decreases monotonically for the learning data. This corresponds to the fact that the maximal tree will always give the best fit to the learning dataset in construct the expected most for the independent data set reaches minimum. Then the increases in multiplicity increases. This reflects the fact overfit and overly complex tree will not perform well into new set of the data.